Okay, so for part 3, now that we know how to locate indices and using the coordinates and the width of the image, we can now try to extract information such as color information for each image that we will be processing. So, for example, going back to the example image that we used on part 2, we still have 7 pixel width and a 4 pixel height, and giving indices or the location of each pixel. Now I added colors. So these colors will represent will be extracted. These color information will be extracted using uh, an algorithm that we will be using, okay? And then storing it in an array. So your background in programming, if you recall, we have arrays. So when we use arrays, or we use arrays to store information to a single variable. The difference with a simple variable and an array is that in a simple variable, you can only store one information, one data. But in an array, we can have multiple um, information. So that is what we'll be using to store the an array to store these information for a certain image. Okay, so going back, we know the index, we know the coordinates, we know the resolution of our image. So for pixel 0 on index 0, coordinates 0, 0, we have um, 125 for the red, 156 for the green, and 213 for the blue. Okay? So we see that the color is bluish because the value for blue is much higher than the red and the green, and it's almost near the maximum value, which is 255. Okay, but it's not pure blue. That's why we have some values in red and in green. Okay, so what we want is to store these three information: the first one for the red, the second one for the green, and the third one for the blue array. You'll see this one: 125, 156, and 213. Okay, so this is for the first index, for the first pixel, and then that pixel has a list in it. So the red, the green, and the blue. This inside the curly braces are all the information that we have for the first pixel, or pixel 0. Okay, so we go to pixel 1. So in pixel 1, the coordinates is 1, 0. Remember, the first one is x, the second one is y. So we're still in row 0 and in column 1. So we get the information. We get the 130 for red, 156 for green, and 217 for the blue. There is a slight difference in terms of values in uh, comparing that to pixel 0, but as you can see, it's very near uh, the color of pixel 0. So just looking at the values for the red, green, and the blue channels, we can already have an idea that okay, so this is bluish in general. It's bluish because the blue channel has the highest value, and it's similar to pixel 0. So without even seeing the actual color, we can get these information already. Okay? So we go to and we'll go to each pixel, but of course, to shorten the lecture, we'll go directly to pixel 6. Okay, so as you can see, the process is row by row. Okay, we go into the first row and go to row 0, and then um, we go into to the different columns along that row. Then we reach the last column for that particular row. So that is 60 for pixel 6. And then we get the information, and then since there is no column, or then there's no uh, eighth column, because there are only 7 pixels for the grid, we'll go to the second row. But we go again to the first column. So that's how the process works. Okay, so from pixel 7, pixel 8, and then go to 9, 10, 11, 12, and then for until the information on pixel 13 is recorded, is stored in that particular array. And then after that, we go to 14, 14, this row, and then until we get to the last column for the last row. So in after that particular process, your array should have a value or a list of values that will look like this, right? So I did not include everything, but just to give you an idea, so the 125.156.213 is the color information for the first pixel or pixel 0, then followed by 130.156.217 for the second, until we get to the last pixel, which has 216, 150, and 72 as uh, the red, green, and blue, respectively. Okay, so how do we do that? We have to create an algorithm. Okay, we have to create a loop of some sort in order for us to create an effective or an efficient um, program. We can't do this manually. Remember, if we have bigger images, then it will be uh, time consuming to go to each pixel and then extract the information. So we have to create a loop or a program for this one. So I've broken down the process into simple terms to create an algorithm. So the first step is to go to the first row of the image. Then we go to the first pixel in the row, or for the first column in the row, and then get the color information. So after we got the information, we save that to an array. And then after that, we go to the next pixel in the row until we repeat that item 3 and 4, meaning getting the information, saving it to an array, and then going to the next pixel in the row until we reach the last pixel in that particular row, in which case we go to the next row. After that, we go to step 2, item 2, going to the first pixel, getting the information, going to the next pixel, getting the information, and then until we get to the last pixel in the last row. Okay, so that will be the process of getting the information, saving it, going to the next, and so on and so forth. So this particular algorithm will be needed uh, as we load a particular image. Then after that, we can process, we can manipulate that image, we can do filter and do some operations on it, uh, afterwards. So this is the first step, just getting the information and then saving it so that we can either display, we can manipulate, we can turn that into a black and white photo or something like that. Okay, so this will be the first part of the image processing. Okay? We have to load the image and then we have to get the information of the image. Okay. So how does the algorithm will look in a code? Okay. Um, for different programming languages, there might be some differences in terms of how it is written, but generally the logic will still will look like this. Okay, so this is using a for loop. So the first part, this is to initialize, and then this will be done during the first part of as the program execute this code. So this will be the first thing to do, and then this will be um, a condition wherein if the answer is true, it will keep on repeating the particular block of code. Okay, and then after doing this, let's say block of code, it will do whatever code we have here. Okay, and then it will keep on doing it until the satisfies the condition given here. And if it no longer satisfies the condition, then it will end the loop. Okay, so that is similar with the next part. Why do we have two loops here? The nested loop is for the width, and the um, the first loop will be for the height or the row. As we go into if you remember the algorithm, we first went into the row, and then we have we go each column or each pixel. And if you see items 5 and 7, there is a repeat or a loop. That's why in this case, the the second loop pertains to the column, and if we reach the last column, we'll go to the next row. So this is how it will look like. The execution, the saving the code for saving to an array will have a different um, will be different depending on the language. So that's why I commented it out. But in at least for an algorithm, we just need to look for the array, set the index. If you remember this, width times j plus I, this pertains to the index of a particular pixel, and then um, the red, the green, and the blue of each pixel using their coordinates will be saved to that array. Okay, so we go to let me visualize how this code works. Okay, so for example, we get the image. There's a note above. It says xy is ij. So in the loop code, we have I and the j. So I pertains to the x coordinate of the pixel, and j pertains to the y coordinate of the pixel. Okay, so as the program executes the loop, it will look like this. So at the start, before before doing the loop, the program will create j, will assign a value to j, which is 0. and then it will check if j is less than the height. Okay, so this is the condition. So you remember the height is 4 because there are 4 pixels in this image. So is 0 less than 4? Of course, the answer is yes. Okay, so it will check, and then since it satisfies the condition, it will proceed to the block of code. However, the next is the block of code that should execute it is another loop. So it will also declare a particular variable, which is I, at the start, and it will assign 0 to I. And then it will check, is I less than width? Recalling the width value, that is 7, because there are 7 pixels for the width. So is 0 less than 7? The answer is yes. So it will proceed to getting and saving the information to the array. So something like this, it will look like image, and then getting going to a particular sorry, the img means that's the name of the array, and then the index for it will be using the index formula that we learned about in part 2, and then just putting the information, um, the red, the green, and the blue. This one, this particular code here is not an actual code. Okay, the image ij.red, that's not the actual code, but this is in a way a pattern that we can use. We'll just have to look for the particular syntax depending on the programming language that you will use. Okay? How to save to an array, a specific index of the array. But at least you'll have an idea how this will work. Okay, and then after that, after executing the block of code, we'll do this last part of the for loop, which is I plus plus. And we say I plus plus is that is an iteration, meaning we add 1 to the current value of I. So that is, since the current value of I is 0, that will be 0 plus 1. So at the end of the code, at the end of that particular part of the loop, I becomes 1. So it will check again if it still satisfies the condition. So is 1 less than width? Of course, the answer is yes. And then um, the code will still be executed. So we get the information from image 1, 0, meaning 1, the coordinate 1, 0. And then, again, there's an iteration that will become 1 plus 1, which is 2. And it will check if is 2 less than 4. Sorry, 2 less than 7 for the width. Since it is, um, it will keep on repeating this code until um, the code reaches the last one. Okay, so at this point, uh, the program will save the color information for this pixel, and then I plus plus once again. So 6 plus 1 is equal to 7. At this point, the value for I is being subjected again to the condition. Is 7 less than 7? Of course, that is not. Um, since the condition is not satisfied, therefore, this will terminate the loop, the loop for this part. And so it will go back to the first loop. And it will iterate. J will iterate. So it becomes 0 plus 1. So J is equal to 1. Now, the condition, it will be checked, is 1 less than 4. Since that is yes, it will go back to the next loop. And then the loop will start at 0 again. But take note that J is now equal to 1. So the code will be uh, the program will now get the information for the second row, going back to the first pixel of first column of that particular row. And then it will go once again until the code goes into 6 3. Well, at least for this particular example, but until it goes to the last pixel, last column of the last row of that particular image. After that, it will once again I plus plus, therefore meaning will now be equal to 7, and this will not satisfy the condition. So it will now add plus 1 to the J. So J will now be 4, and it will check if it satisfies the condition, which it won't, because 4 is not 4 is not less than 4. Therefore, at this point, the loop will end, and you the process of getting the information, saving it to an array, will now stop. But we already have the array. We already have the information for that one. So that is the how it will look like, how your code will look like if we get the information for each pixel. Okay, so that will be the end of the digital image just basics. And in the next um, in the next few lectures, we will now discuss how we um, process, or how we get those information. Remember, we already saved the information, the color information. Now we are going to manipulate them in the next several lectures. So we'll now um, do some uh, what do you call it? Converting it to a black and white, or changing it to a sepia color, or something like that. So we'll now be processing images. So this part will just be about the basics, and just getting the color information first, because we will be using them in our future session.